Hello students, welcome to the class. Our next question is, a fireman of mass 60 kg slides down a pole. He is pressing the pole with a force of 600 Newton. So a fireman of mass 60 kg, the mass of the fireman is given, and with what force he is pressing the pole, that force is given. The coefficient of friction between the hands and the pole is 0.5. So coefficient of friction, that is mu value, is given. With what acceleration will the fireman slide down? So in the bracket they have given acceleration due to gravity also, that is 10 meter per second square. Coefficient of friction is there. Then force is given 600 Newton, and the mass of the fireman, it is also given 60 kg. We need to calculate with what acceleration will the fireman slide down. So we need to calculate the acceleration. The formula which we can use here is we know that friction is equal to, so frictional force F is equal to what we can write? We can write it as mu into R. So the mu value is, it is 0.5 into R value is, it is 600. So 0.5 into 600, this is nothing but 300 Newton. This is 300 Newton. Then the weight of the person is given. The weight of the person is 600 Newton. Correct. Now here we can write MA is equal to W minus F. Correct. We need to calculate acceleration. Therefore, acceleration is equal to weight minus force divided by mass. So this is 600 minus force is how much? Just now we calculated, that is 300 divided by mass. It is given, it is 60 kg. Okay. So 600 minus 300, it is 300. 300 divided by 60. So 300 divided by 60 is nothing but what? 5 meter per second square. So this is the acceleration, that is option D is the correct option here. Option D is the correct option, 5 meter per second square. So if you want to understand this with the help of a figure, then we can consider this as a pole, and here the fireman is climbing up. His weight is acting downward. Then this is the force, and here it is, he is pressing the pole. So here the pole is there. So he is pressing the pole with 600 Newton force. So this is what? Normal reaction. Okay. We need to calculate with what acceleration he is climbing up. Correct here. The answer is option D, 5 meter per second square. We need to use friction formula, frictional force formula. We need to use acceleration is equal to W minus F divided by M. These are formulas we can use. So the correct answer is option D, 5 meter per second square. Then let us see our next question. If a cyclist moving with a speed of, so if a cyclist is moving with a speed of 4.9 meter per second on a level road, can take a sharp circular turn of radius 4 meter. So radius is given, the speed of a man is given, it is 4.9 meter per second. Then coefficient of friction between the cycle tire and the road is. So coefficient of friction we need to calculate. Here they have given that it is a level road. It is a level road. So when the question is based on the level road, we have the expression for speed, that is V is equal to under root of mu into R into G. Here what we need to calculate, they have asked you the coefficient of friction, that is mu value, that is mu is equal to, so we can square on both the sides. So if I square it on both the side, it becomes V square. Mu is equal to mu Rg. Therefore I can transfer this Rg here, it becomes V square divided by R into G. So V value is given, the speed value is there, that is 4.9 whole square. divided by r value. The radius value is given, it is 4 into acceleration due to gravity. So here I will take it as 9.8, that is mu is equal to. So 4.9 into 4.9 divided by 4 into 98. 4.98, sorry, it is 4 into 9.8, that is acceleration due to gravity. So if you simplify this, the coefficient of friction will be around 0.61. The coefficient of friction will be 0.61. So here the correct option is option C. Option C is the correct option, 0.61. I hope it is clear to you, students. Then let us see the next question. Direct question it is. A boy on a cycle pedals around a circle of 20 meters radius at a speed of 20 meter per second. The combined mass of the boy and the cycle is 90 kg. See here, a boy is pedaling a cycle in a circle of 20 meter radius. The radius of the circle is there given. Then the speed, with what speed the person or the boy is moving, that is also given. It is 20 meter per second. Then next, the weight of the boy and the cycle, combining both, the weight is 90 degree. The masses, sorry, the mass is 90 kg. The angle that the cycle makes with the vertical so that it may not fall is. So you need to calculate theta value here. Okay. It is a circular path. What all quantities are given? Mass is there. Radius is given 20 meter. Then next, speed is also given, that is 20 meter per second. Then next, acceleration due to gravity, that is 9.8. That is theta is equal to tan inverse of v square divided by r into g, which is equal to tan inverse of v value. So it is 20 whole square divided by r is 20 into g. So either you can take 9.8 or 10 also you can take. So if you simplify this, that is 20 square divided by 20 into 9.8. So here if you take 9.8 or if you take 10, small change in the value you will get. Okay, so 20 square divided by 20. So you can cancel here 120. 20 will get cancelled. So it is 20 divided by 9.8. Or if you want, just roughly you can do the calculation as tan inverse of 20 divided by 10. Means instead of taking 9.8, I can take it as 10. So this 0, 0 will get cancelled. Therefore, you are getting it as tan inverse of 2. So what is the value of tan inverse of 2? It is 63.90 degree. The 63.90 degree. Okay. So here, this is the formula to calculate the angle theta when the cycle makes with the vertical so that it may not fall in a circular path. So this is how you can do the calculation. Then next, our next question is, so correct option is option B, that is 63.90. Option B, 63.90. Next question. The slope of the smooth banked horizontal road is P. The slope of the banked horizontal road is what? P here. If the radius of the curve B R, if the radius is R, The maximum velocity with which a car can negotiate the curve is given by. So here a car is moving in a curved path. Okay. The moment, the slope of that road, it is given, it is P. If the radius of the curve is R, then what you need to calculate? You need to calculate the maximum velocity or the maximum speed with what the car will take a turn. So how you can do this one is, here we know that just now we used the same formula, that is tan theta is equal to V square divided by R into G. It is V square divided by R into G. The moment, the slope is nothing but what in the question it is mentioned that it as P. So P is equal to V square divided by R into G. Therefore, what they have asked you, they are asking you to calculate the velocity. So keep this velocity term here only. You can transfer this RG. Therefore, it becomes P into R into G, as it is V square, which implies V is equal to under root of PR into G. V is equal to root of PR into G. So the correct option is option B, root PRG. P is slope, R is the radius, and G is acceleration due to gravity. G is acceleration due to gravity here. Okay. Option B is the correct option. Let us see the next question now. Two cars of masses m1 and m2 are moving in a circles of radii r1 and r2 respectively. So two cars are there, they are moving in a circular path of radii r1 and r2. Their speeds are such that they make complete circles in the same time t, the ratio of their centripetal acceleration. So here you need to calculate the ratio of centripetal acceleration. The only data what they have given, mass is m1, m2 of the two cars, and the radii is r1 and r2. Here we can use the formula of centripetal acceleration. So see here, we know that centripetal acceleration AC is equal to omega square into R. Therefore, we also know that omega is equal to what? 2 pi divided by T. We know this one. And what they are saying, they are in the same time interval. So when it is in the same time interval, we can say that as T1 is equal to T2. This implies omega 1 is equal to what? Omega 2. Why? Because see here omega is equal to 2 pi by T. 2 is constant, pi is constant. So T also what they are saying, it is same. Therefore, we can also say that omega 1 is equal to omega 2. So we can write it as A1 divided by A2 is equal to R1 divided by R2. We can write it as R1 divided by R2. Why? Because here see, centripetal acceleration is equal to omega square into R. Omega, we are saying that for both the car it is same, omega 1 and omega 2. Okay, therefore it becomes R1 divided by R2. That is option B is the correct option. R1 is to R2. Option B is the correct option here, right? Then our next question. A player caught a cricket ball of mass 150 gram moving at a rate of 20 meter per second. So mass of the cricket ball is given, it is 150 gram. It is moving at the rate of 20 meter per second. If the catching process is completed in 0.1 second. So here they have given the time interval as 0.1 second. The force of the blow exerted by the ball on the hand of the player is. You need to calculate the force. To calculate force, we have time, mass, and speed is also given. Okay. We can use the concept of impulse here. Why? Because force and time relation. That is nothing but what? Impulse formula. So as we know that force into time is equal to what? Impulse I. So we also know that this is equal to what? Change in momentum. So while discussing the synopsis, we discussed that. So impulse is nothing but force into time. This is also is equal to what? Change in momentum. Therefore, we can write change in momentum is equal to mass is how much? 150 gram it is given. We need to take it in terms of kg. So it is 0.15 kg into bracket. So change in velocity or the speed, that is 0 minus 20. This is equal to. So this is equal to 3. So change in momentum is what? 3 here. But we need to calculate force. Therefore, F into T is equal to change in momentum is how much? 3. Therefore, F is equal to 3 divided by the time interval is 0.1. So 3 divided by 0.1. 3 divided by 0.1, it is nothing but 30 Newton. It is nothing but 30 Newton. That is option D is the correct option here. Okay. So we know that impulse is equal to change in momentum. So change in momentum, calculate the change in momentum value by using the formula mass into velocity. Then next, you can substitute that in the first equation, that is F into T is equal to 3. Now force F is equal to 3 divided by 0.1. That is nothing but 30 Newton. So the correct option is option D. Next question. Consider a car moving on a straight road with a speed of 100 meter per second. So the speed of the car is given, that is 100 meter per second. The distance at which car can be stopped is mu k is equal to 0.5. The coefficient of kinetic friction is given and the speed is given. We need to calculate distance here. Okay. We have, that is, retardation due to friction is equal to mu into g. We also know that v square is equal to u square plus 2a into s. So here a car is moving on a straight road with a speed. So here the car is stopped at the end of the journey. Therefore, final velocity will be 0. Initial velocity is 100. As it is u square, it becomes 100 square minus 2 into mu into g into, yes, that is acceleration, retardation, acceleration. So here you can see this concept, that is acceleration or retardation is equal to mu into g, which we have written here. Therefore, here if I simplify this 100 into 100, okay, so minus 2 mu g into s is there. I can take it on the other side. It becomes 2 mu g into s is equal to 100 square. Right? We need to calculate the distance value, yes. Therefore, it is 100 into 100 divided by 2 into mu value is 0.5 into g value is 10. Into g value is 10. So if you simplify this, you are going to get the answer as 1000 meters. The correct answer is 1000 meter. That is option D. Option D is the correct option here. right? So retardation due to friction is equal to, it is mu into G. We have a formula, V square is equal to U square plus 2AS. That is 0 is equal to, simplified for distance traveled, that is yes. Okay. Let us see the next question. Bullet fired into a fixed target loses half its velocity after penetrating 3 centimeter. So a bullet is fired from a gun. It is fixed to a target, but it loses its half velocity after penetrating 3 centimeter. How much further it will penetrate before coming to rest, assuming that it faces constant resistance to motion. So we need to calculate the distance, means how much distance it will travel, even though its velocity is decreasing, how much distance it will travel before coming to the rest. So again, we can use the equation of motion formula and we can simplify this. See here. So for the first part of penetration, penetration, we can write it as u by 2 whole square is equal to u square minus 2a into s. So directly I am substituting the value of s, that is 3 centimeter, which is given. Why I have written here, the formula is what? V square is equal to u square plus 2as. Here, after traveling half, it loses the velocity. It loses the velocity here. Therefore, the final velocity becoming u by 2. Therefore, I have taken it as u by 2 whole square is equal to u square minus 2a into bracket 3. Or we can also write it as u square is equal to 8 into a. So here you can simplify this, students. It becomes u square by 4. Then you can take u square terms one side and you can simplify. U square is equal to, it is becoming 8a. So this is for what? First penetration, first part of penetration. Then for the later part of the penetration, we can write it as, so the same formula we can use, but now the final velocity is 0. That is 0 is equal to u by 2 whole square minus 2 into a. So instead of x, I'll take it as x. So this only x value we need to calculate. So again, simplify. What you can do here, you can write it as u square is equal to 2a into x. That is nothing but, so u square value already we know. What is the value of u square? It is 8a and here it is 2a into x. So this implies we need to calculate x itself. Therefore, x is equal to a will get cancelled. It is 8 divided by 2. So 8 divided by 2 is how much it is? So here it is. This implies what? U square divided by 4 is equal to 2a into x. What I am writing? So here it is 0 is equal to u by 2 whole square minus 2ax. I can write it as u square divided by 4 minus 2ax is there. So if I take it on the other side, it becomes plus 2x. Then next, that is u square is equal to, it is 4 into 2, it is 8 a into x. But see here, so from this equation we have u square is equal to 8a, that is 8a is equal to 8a into x, that is x is equal to what? 1. So the correct option is option B, 1 centimeter. Option B, 1 centimeter is the correct option. Okay. Then our next question. two masses m1 and m2 are attached to the ends of a string which passes over a pulley attached to the top of an inclined plane. The angle of inclination of the plane is theta. Take g is equal to 10 meter per second square. So masses they have given, m1 is 10 kg and m2 is 5 kg. Theta value is also given, it is 30 degree and g is 10 meter per second. We need to calculate the acceleration of m2. So here there are two masses which is attached to the ends of a string, okay, on an inclined plane. So the angle of inclination is 30 degree. Then next we need to calculate the acceleration of m2. So to calculate the acceleration of m2 we have acceleration a is equal to m2 minus m1 into sine theta divided by m1 plus m2. So into acceleration due to gravity, that is g. So which is equal to m2 is how much it is given, it is 5 minus, so m1 is 10 into sine theta, so here it is sine 30 divided by m1 plus m2, that is 5 plus 10, that is 15, and here this g I'll write as it is for time being. This is equal to, so sine 30 is 1 by 2, so 1 by 2 into 10, that is 5. So 5 minus 5 is 0. 0 divided by 15. So anything divided by 0, what is the answer? That is 0. So the correct option is, that is option D, 0 is the correct option. Next question. Two blocks are attached to the two ends of a string passing over a smooth pulley as shown in the figure. So I'll just show you the figure. The acceleration of the block will be, so the acceleration of the block is given. Block you need to calculate, the acceleration you need to calculate. They have given the angles here, means the angle between the pulley and the inclined plane it is given. So they have sine 37 degree it is given, sine 53 degree it is given already. Okay. So in the figure they have given the mass value is also, the figure is something like this. So two blocks are attached to the two ends of a string. So here you can assume that is one surface is there. Here you can assume the pulley at one side, at other side. Here the masses are also there. So in the figure only it is given, and here it is 100 and here it is 50. Okay. So here the figure is it is there already, but I did not paste it here, right? So masses are given. The masses are 100 kg and 50 kg. The acceleration of the block you need to calculate. The angles are given. So here whatever the angle is made, that angle is already given. The formula for acceleration is equal to m1 into g sine alpha minus m2 into g sine beta. Minus m2 into g sine beta whole divided by m1 plus m2. So this is equal to, so mass is 100 into g, you can take it common. Okay, so here I can write it as sine 37 minus 50 into sine 53 divided by 100 plus 50. So if you simplify, so sine 37 and 53 value it is already given. So if I simplify, it becomes 0.133. So 0.133 meter per second square. That is what? That is the acceleration of the block. Okay. So option B is the correct option here. Option B is the correct option. Then let us see the next question now. Next question is, a block of mass 7 kg is placed on a frictionless table. A thread tied to it passes over a frictionless pulley and it carries a body B of mass 3 kg at the other end. So here the acceleration of a system you need to calculate. Again, the acceleration concept and the mass concept. So already in the previous example, see here students, based on this we have solved questions. So this type of questions are important also for your exam point of view. Okay, so here I can take the acceleration as acceleration is equal to m2 divided by m1 plus m2 into g. So this is masses, it is already given. Here it is 3 divided by 7 plus 3 into g is 10. So this is equal to 3 divided by 11 into 10. So if I simplify this, sorry, so 7 plus 3 it is 10, 10, 10 will get cancelled. Therefore, you are getting it as 3 meter per second square. The acceleration is 3 meter per second square. So the correct option is option B. So this formula already we have used in the previous example. So simple, just substitute the masses and calculate. Okay, now next question is, on a smooth plane surface, two blocks A and B are accelerated up by applying a force 15 Newton on A. If the mass B is twice that of A, the force on B is, you need to calculate the force on the B. So here you can take the figure like this. Here you have a smooth plane surface. Okay, two blocks A and B are accelerated by applying some force. So here that boxes are there. They are accelerated by applying a force of 15 Newton. So here you can assume it as A and this one you can assume it as B. They are saying that the mass of B is greater than the mass of A. Then we need to calculate the force on B. So on force, the force which is applied on B, we need to calculate. On A, it is already given. Okay, so first here the force is given. The force is 15 Newton. See here they are saying that these two bodies are lying on the surface. Therefore, the net force, sorry, the net mass will be how much? Suppose if I assume that the body A is having, suppose if I assume that the body A is having mass m and the body B, they have given that it is twice of A, that is 2m. Therefore, the total mass will be 3m. The total mass will be 3m. Now, so now what we can do, now we can write it as, that is force is equal to mass into acceleration. So if the body is the net acceleration, I can calculate it as acceleration is equal to force divided by m. So force is 15 Newton, mass is 3m is equal to acceleration, which implies that the acceleration is 15 divided by 3m meter per second square is the acceleration of the body. Now here, according to Newton's third law, the A body is exerting force on B body is exerting force on A body. So now I can take it as the force on B is equal to mass into acceleration. So mass is 2m and acceleration is, just now we have calculated, is 15 divided by 3m. So this m will get cancelled. 3 ones are 5 za. So 5 2 za 10. So 10 Newton is the force applied on it. So the correct option is option C, that is 10 Newton. Okay. So I hope it is clear to you what we did. We need to calculate the combined mass, then combined acceleration. Then on B, what is the force? We can simplify. So the force on B is, it is 10 Newton. Okay. Let us see the next question. A bucket tied at the end of a 1.6 meter long string is reeled in a vertical circle with constant speed. Okay, the length is given. What should be the minimum speed so that the water from the bucket does not spill when the bucket is at the highest position? So we need to calculate at what position the bucket is there at the highest position so that the water is not coming out of it. Okay, so see here, since water does not fall down, therefore the velocity of revolution should be just sufficient to provide centripetal acceleration. Therefore, we can write, so when it is possible, when it is providing the centripetal acceleration, therefore we have the formula, that is V is equal to root of G into R, that is equal to root G value is how much? It is 10 into R value they have given it as 1.6. So 10 into 1.6 it is 16. So root of 16 is how much? 4. So the correct option is option A, means it should be at the point of 4 meter. It should be at the speed of 4 meter per second so that the water will not come out of the bucket when it is at the highest position. So the correct option is option A, 4. Then our next question. The minimum velocity with which must traverse a flat curve of radius 150 meter. And the coefficient of friction is given, that is 0.6 to avoid the skidding. So how we can do this one here? Again, it is a curved road. We need to use the concept of limiting friction is equal to what? Mu s into R. That is equal to mu s into m into g. So mu s is how much? It is given 0.6 into mass is 1 into g is 9.8. So 0.6 into 1 into 9.8, it is nothing but 5.8. Sorry, we can use, we need to calculate the minimum velocity, not the limiting friction. Okay, the minimum, the velocity formula we need to use. That is velocity is equal to under root of mu r into g. That is equal to mu is 0.6 into r is 150 into g is 10. So velocity formula, direct formula. So the simplification is 30 meter per second. It is 30 meter per second. So this one is the option B is the correct option here. Speed is equal to root of mu r g value substitute and calculate. Right, students? Let us see our next question. What minimum coefficient of static friction is required if the person on a ride is not to slide downward to the new position of the floor? To the new position of the floor. So here what you need to calculate now? You need to calculate the minimum coefficient of static friction. The minimum coefficient of static friction. So to calculate the minimum coefficient of static friction, so we can use the formula. See here, to find the minimum static friction, we have R is equal to mv square divided by radius r. Okay. So now this is equal to the normal for reaction or the normal force. We can write it as mu s into v square mv square by r is equal to m into g. Therefore, mu s is equal to what we can write now? We can write it as r into g divided by v square. So this implies r value. The question is a little incomplete here, students. They have given the value of r also. The r value, it is given as 2.5 and g value is 9.8. The speed value is also given, it is 9.4. Okay, so if you simplify this, you will get it as 0.2. 0.28. If you get it as 0.28, the minimum coefficient of static friction is required if the person on the ride is not to slide downward to the new position of the floor. Okay, so here they have given the value of R and V value. So in question it is little missing. So the value of R is 2.5 and the value of G is 9.8. The value of V is 9.4. Substitute, you will get 0.28. The option A is the correct option. Option A is the correct option here. Okay, so here the direction of impulse is, so next question is the direction of impulse they are asking. So what is the direction of impulse? Option A, same as that of the net force, opposite to that of the net force, same as that of the final velocity, same as that of the initial velocity. So the option is, correct option is option A. Option A is the correct option, same as that of the net force. Option A is the correct answer. Then our last question is, a horizontal force 10 Newton is necessary to just hold a block stationary against a wall. The coefficient of friction between the block and the wall. So coefficient of friction is there, force is there, we can calculate weight. So weight is equal to what we can do. See here, we can use it as the weight mg is equal to, so the weight mg is equal to mu into F. The coefficient of friction is there, 0.2 into 10, that is equal to 2 Newton. That is option A is the correct option. Option A is the correct option because weight is equal to mg. So W is equal to F into mu. Option A is the correct option here. So this completes our laws of motion synopsis and the questions. Okay, students, just go through it and similar problems you can solve. Thank you.